Now let's assume we really want a case-insensitive comparison here, which will recognise these two food items, apple with and without a capital A, as being equal. You might be tempted to modify food item to do that, but that would cause food item's equality behaviour to change everywhere, and that might not be what you want. Besides, we've already said that, for general purposes, food items equals implementation is a very good one. If we just want to have case-insensitive comparisons here, then the way to do that is to write a custom equality comparer. So I'll create a new class, I've called it Food Item Equality Comparer, and I will say that it implements iEquality Comparer of food item. And I'll just ask Visual Studio to implement that. And we can see that unlike for iComparer of t, there are not one but two methods. There's an equals method, which takes two food item instances, and obviously the point of this method is to test whether those food items are equal. And there is a getHashCode method, which takes one food item instance. This roughly matches the fact that when implementing equality earlier on, we saw that we needed to implement objects.getHashCode too, in order to provide a hash value that matched our equality implementation. The same thing is going on here. Our equality comparer will provide a new definition of equality, so it needs to be able to provide hash codes to match. This is only needed for equality comparers, not for ordering comparers. The reason is that comparers are not intended to be used in scenarios that require hash codes. Now I've written the food name equality comparer by directly implementing iEquality Comparer of food item, because I wanted to show you what the iEquality Comparer of t interface looks like. However, just as for iComparer of t, best practice is not to implement the interface directly, but to derive from a base class that Microsoft has already provided. In this case, the base class is called Equality Comparer of t. So I will just change the interface implementation declaration so that we have Equality Comparer of food item as the base class. And just like before, I also need to say that these two methods are override methods, because now we are actually overriding abstract methods in the base class. Equality Comparer of t implements both the generic iEquality Comparer of t interface and an equivalent non-generic iEquality Comparer interface by plugging in these overridden methods. So just like happened for our custom comparer a while back, you get both the generic and the non-generic interfaces, but you only need to provide one implementation. Now, also just as for the comparer, our equality comparer should probably be a singleton. So I'll just add the code for that. As before, we have a private constructor and a field and property to return the singleton instance.